Magandang umaga, tanghali, hapon at gabi mga Kalavarn. Narito na naman kami upang handungan kayo ng makabagong impormasyon. Lalavarn ka ba? Lalavarn ka ba?
Eslavarn!
Lalavarn ka ba?
Eslavarn!
Lalavarn ka ba?
Eslavarn!
Lalavarn ka ba?
Eslavarn.
Lalavarn ka ba?
Eslavarn.
Ball Bounce Experiment. In this activity, the materials needed are a basketball and a smaller bouncy ball. Step 1. From the same height, drop the basketball and the tennis ball side by side to compare their bounces. Step 2. Make a hypothesis about what will happen when you stack the smaller ball on top of the bigger one and then drop them together. Let's examine. In this experiment, we can see that the smaller ball was resting at the top of the bigger ball until the bigger ball bounced off. Penny on a card experiment. In this activity, the materials needed are drinking glass, a playing card, and a coin. Step 1. Put a playing card on the top of the drinking glass. Step 2. Put a coin on top of the card. Step 3. Flick the card out from under the coin. Now let's see what will happen. It was shown in the experiment that the coin fell inside the glass even if it's flicked away. We can say that Newton's first law of motion can be applied in this experiment. Dynamic trolley. In this activity, the materials needed are ruler, clamp, 4 pieces of 100 gram slotted masses, dynamic trolley, pulley, and string. Step 1. Select the falling mass to be 100 grams. Pull the trolley back so that the mass is raised just below the pulley. Step 2. Repeat this measurement from the same starting position for the trolley several times. Step 3. Transfer 100 grams from the trolley to the slotted mass. To increase it to 200 grams, release the trolley from the same starting point as before. Repeat this several times. Step 4. Repeat step 3 for slotted masses of 300 grams and 400 grams. Now, let's observe.
Go. Go.
The result of this experiment shows that there is a change in the speed of the trolley every time there is an added weight. The second law of motion can be seen in this experiment. Alka-Seltzer rocket. In this activity, the materials needed are empty film canister, Alka-Seltzer tablet, teaspoon, and water. Step 1. Remove the film canister's lid. Break off a quarter of one tablet and place it on the inside of the canister lid. Put 2 to 3 teaspoons of water into the empty canister. Step 2. Tip the canister and snap the lid shut. It is important to have a tightly sealed lid. Step 3. Gently shake the canister for a few seconds. Make sure that the lid is tightly secured. Step 4. Place the film canister on a flat surface, upside down. Move away from the setup quickly and observe what will happen to the canister. Now, let's watch. In this experiment, the canister flew upwards because of the Alka-Seltzer dissolved in the canister. The particles inside caused this motion. Roll, roll, roll the ball gently down the plane. In this activity, the materials needed are basketball, volleyball, plywood, and table. Step 1. Let a basketball roll on a plane inclined at about 30 degrees with the horizontal and ask another member of the group to stop it on the lower end of the inclined plane. Step 2. Repeat the same procedure using a volleyball released from the same position. And determine which ball is harder to stop, basketball or volleyball. Why? What should you do to make the other ball harder to stop? Now, let's see. In this experiment, the results show that the heavier the ball is, the harder it is to stop. It is much easier to stop a ball with a lighter weight. Please release me, let me go. In this activity, the material needed is basketball. Step 1. One student throws a ball to each of the other members of the group. The station leader should throw the ball to each member with the same amount of force. Step 2. The first catch, chest pass, should be done without moving the hands backward along the motion of the ball. Step 3. For the second catch, overhead pass, the hands are moved backward along the motion of the ball. And answer in which catch was a greater stopping force felt. Is it the chest pass or the overhead pass? Why? Why is it good idea for the receiver to extend his hands forward to catch the ball? Let's see. The experiment demonstrated that it is harder to stop a ball using a chest pass, and it is easier to catch a ball if you use the overhead pass. Don't break my heart, my eggy heart. In this activity, the materials needed are empty sack of rice and an egg. Step 1. Using an empty sack of rice, catch the egg that will be thrown away from a certain height. And answer, did the egg break after the impact with the sack? Why? Let's look. The results showed that the egg did not break after hitting the inside of the sack, even if it was dropped from a certain height. Hit that wall one more time. In this activity, the materials needed are basketball and paper clips. Step 1. Throw the basketball horizontally against a concrete wall. Step 2. Using a paper clip, mark the point where the ball first strikes the ground after hitting the wall. Step 3. From the same position, repeat the step 1 but with a greater force. And answer, in which throw did the ball hit the ground farther from the wall? Is it the first throw or the second throw? Why? What does the longer distance traveled by the ball from the wall say about the velocity of the ball after impact with the wall? Compare the momentum of the ball in the two throws, just before it hits the wall and just before it leaves the wall. Explain. In which throw is the impact force greater? Is it the first throw or the second throw? Why do you say so? Let's discover. In the first throw of the ball, it landed in between the wall and the thrower, while in the second throw, the ball landed near the thrower because there was an added force to the ball.
Magandang umaga, tanghali, hapon at gabi mga kalabar. Narito naman.
Baka mahimbing ka ba?